All right, guys, we are going to start chapter 17 today. So, chapter 17 is actually kind of easy. There's just kind of a lot of terminology to learn again, but it sort of makes sense. I don't think it's as bad as that mixture chapter where you're just learning things that you don't really know. All right, so chapter 17 is called Elements and Their Properties. There are 3 sections. Let me hit present here. All right, so there are 3 sections. First one is called metals, which is what we're going to do today. Lesson 2, nonmetals, and lesson 3, mixed groups. So basically the idea here is that elements are classified into 3 different groups within the periodic table: metals, nonmetals, and metalloids. Okay, so based on their position, I can predict which one of the 3 of those things they are, and then their qualities. Okay, so section 1, metals. The questions here are: what are the properties of a typical metal? How do atoms bond in metallic bonding? Which elements are alkali metals and which are alkaline earth? And what are some common uses of the transition elements or transition metals? Okay, so there's your vocabulary. So this is super duper duper important. It is, let me stick myself down here. Ooh, there we go. I moved myself. All right, so here we go. These are very important vocabulary words here. So metals are shiny, ductile, malleable, and good conductors of heat and electricity. Okay, they are all solids at room temperature except for mercury. That is the only exception. Okay. Oh, I will have to go back. All right, so we call that shiny property luster. Luster is the ability to reflect light. So metallic luster is shiny. Malleable, which is a funny word, but it means I can hammer it into sheets without shattering. So if I take a hunk of iron out of the ground and I hit it with a hammer, it will flatten out into a sheet. Okay, that's malleable. Metals are also something called ductile, and I have included an amazing video for you about candy canes, because candy canes are ductile as well, and it's much more exciting than watching them make wire. So basically, if I take a hunk of metal, like iron, out of the ground, and I pull both ends of it, it will pull into a wire, okay? And that's how candy canes work as well. And then they form something magical called a metallic bond, okay? So we've been talking with Bohr structures about how the electrons are arranged in levels. Metals kind of, they do that, but they also kind of don't hold super tightly onto their electrons. So they kind of release them. So all of the electrons in a piece of metal are kind of freely forming or freely floating, sort of. And then as an atom needs an electron to balance itself out or to conduct electricity or heat, it grabs and releases them. So we call the electrons in a metal kind of a sea of electrons, okay? And that's why they do all of these qualities. That's why they conduct heat and electricity so well, okay? Definitely watch the candy cane video. Alkali metals. So the first group on the periodic table, so we are working across the periodic table. We're going to start on the left-hand side. The first group, group 1, is called the alkali metals. Okay, alkali is an Arabic word that means fire. Okay, so these elements are super reactive. So they have all of those normal metal properties. They're shiny, ductile, malleable, good conductors. However, these are all soft. Okay. If you watch Hunting the Elements, please go watch it, okay? They showed you a hunk of sodium, and it looked like almost like cream cheese, like shiny cream cheese, okay? And you can cut it with a plastic knife, okay? Then they used that to make salt, remember, for the popcorn. Watch the video. It's cool, and it explains all of this and shows you stuff I can't. So they're very soft. They are still shiny, but they're soft. They're the most reactive of all the metals. They react really rapidly and violently with water and oxygen. So if I had, say, sodium in my hand, and you saw this in the video, it would start sparking just like you see up here in this Petri dish, okay? They're so reactive that they don't occur naturally in Earth's crust. So anytime I need one of these metals, I have to separate it from whatever compound it's formed. Oh gosh. And if I go upstairs in the school to the chemical room, if I need a sample of one of these things, they're actually all stored in oil because they're so reactive with oxygen and water. Okay. Group 2, alkaline earth metals. I know it sounds a lot like group 1, but it's different. So these were all called the earth metals because if you take these elements and or compounds made with these elements and you throw them into a fire, they don't burn. They have super duper high melting points. And we use a lot of them in fireworks, actually. So they are all shiny, ductile, malleable, all that stuff, okay? But they're pretty reactive and they react very well. So we usually find them in compound form, okay? And again, they don't burn. So those are the two oldest kind of element groups on the periodic table, okay? Then we're going to move to the middle part of the periodic table, the part that kind of sits down. Okay, we call those the transition elements. They're groups 3 through 12. Okay, I personally call them the transition metals because they're all metals. Iron, gold, all of those elements that you think of as metals are pretty much in this group. They're less reactive than groups 1 and 2. They're pretty stable in room temperature. Some of them are found in nature in their elemental form. Like I can go get a hunk of gold or a hunk of silver or a hunk of iron out of the ground as an element. Okay. We call them the transition metals because they kind of transition from group 1 and 2, the super reactive, to groups 13 through 18, which are not metals at all. So as you go across the periodic table, they gradually lose their metallic properties. Your book specifically mentions these two groups within the transition elements. It mentions the iron triad, which is iron, cobalt, and nickel. They're found right next to each other in a little cluster. They're the most common magnetic metals found on Earth. Okay, we use them in steel, other alloys. If you watched the Hunting the Elements video, they did the bell section where they showed you how alloys worked, and they actually took you to an electron microscope to analyze the bell that they made. And then the coinage metals are another group of metals that are close together. It's copper, gold, and silver. We use them to make coins. They're stable, they're malleable, they're found in nature in their elemental state, okay? They're all very good conductors, so we use them a lot in circuits and things like that in wire, okay? And then we have the inner transition elements. So in most periodic tables, they sit below the table, okay? And then I always told you guys they would fold up like a map and shove themselves into the periodic table. The periodic table here at the bottom of the slide actually shows you what the periodic table would look like if we stuck it in, okay? These are all pretty uncommon. In the video, they call them rare earth metals. Again, watch Hunting the Elements. I'm telling you, just watch it. I know it's long. It's okay. These are all pretty rare. Some of them are man-made. They're all kind of radioactive and difficult to separate. And not very common, but there you go. And lastly, your book talks a little bit about metals in Earth's crust, okay? We find metals in the rocks in Earth's crust, okay? Most of them are combined into compounds, some of them are not. If we find them, we usually call them ores, especially if we can mine them for profit. Profit is the key word there with ore. And then they don't always look exactly like what you would imagine them looking like, which I showed you guys over the year. Okay, this particular set of slides I found has kind of assessment questions. So the question is, when magnesium and fluoride react, what type of bond is formed? Okay, we haven't actually talked about this, but the correct answer is ionic. We will talk much more about this next chapter. What type of bond is found in pure gold? Since it's only bonding with itself, it is a metallic bond. Because electrons move freely in metals, metals are conductors. Remember how I talked about metallic bonds in the sea of electrons? Much more on that next chapter. Which elements are least reactive? Noble gases, but again, we won't get to that until the third section. I'm not real happy with these slides, but that's okay. Back to the essential questions, because that's why we're here. What are the properties of a typical metal? They are ductile, malleable, shiny, good conductors of heat and electricity, and they form metallic bonds, okay? Watch the candy cane video. How do atoms bond in metallic bonding? So a metallic bond is different metals or the same metals that kind of release their electrons into a sea of electrons, and that allows them to conduct electricity. Which elements are alkali metals and which are alkaline earth? Alkali metals are group 1. They're more reactive. They react to air and water. Alkaline earth are group 2, and they're slightly less reactive, but only found as compounds. What are some of the common uses of the transition elements? These are your typical metals that you think of, so we use them for coins and building materials and things like that. And those are the questions you are responsible for and are due this week. Have a wonderful day, everybody. Miss you guys a ton.